Faraday's law describes how much potential is induced when you change the magnetic flux through a wire. If you combine that with Ohm's law, you can see that an induced EMF will actually produce a current. But what direction will this current flow? That's what Lenz's law tells us. In general, the induced current flows in whichever direction is needed to counteract the change in flux of the original magnetic field. This is a really complicated statement, so it's best to work through this in an example. So let's say we have a loop of wire with a bar magnet nearby. I'm going to move this north end of the magnet closer to the wire, and we're going to predict which direction the current would flow in this loop. The first step is to identify the area vector and point it in the same direction of our magnetic field. So here, at the perspective of the loop, the magnetic field points to the right. So I'll define A to point to the right. That takes care of this pesky negative sign and makes sure that we don't have to ever flip anything later on. The next step is to figure out how the magnetic flux is changing. As I move this magnet into the loop, my magnetic field strength is going to get bigger. Well, if B gets bigger, that means my magnetic flux will get bigger. Therefore, the magnetic flux is increasing. Now, that is really useful for step 3, which is what Lenz's law actually is. Because I have an increasing magnetic flux, the current that's produced will want to oppose that to get it back to what it was before. So in this case, if flux is increasing to the right, it's going to induce a magnetic field to the left to counteract that flux. So if I know my induced magnetic field is pointing to the left, the fourth step tells me to use a right-hand rule to determine the current through that wire. If I point my thumb in the direction of the induced magnetic field and I curl my fingers, I will see that if I have it left, the current has to go in this direction. Now you can change this up in all sorts of ways. Instead of having the north end move into the magnet, have it move away. See what happens to the flux, the induced magnetic field, and the direction of the current as a result. Think about what if it were the south side, moving in or out. What if you keep the magnet still and move this wire back and forth? What if you spin it? In all cases, just figure out how is the flux going to change and what that will do to create my induced magnetic field.